Hello, this example was done as part of the previous lesson as well, but the screen share didn't work, so all the details was lost. So I'm just doing this again, and I'm going to explain it. Just to give some background, we're trying to find the volume of this blue curve spun around the y-axis. And we said previously that we could try to first get the volume of the cylinder and then get the volume of the area under the curve and then subtract the two, but it's a lot more work. So we're just going to do the easy way, and I'm just going to start with some preparation. We know y is equal to x squared, and because we're going to integrate over the y-axis, our x will be the distance, which will then be the square root of y, and our volume will be the integral of 0 to 25 of pi times square root of y squared dy. Okay. The reason for that is we kind of build the shape up out of discs, round discs, and each disc has got an area of pi times square root of y, the radius squared to y. Okay. Now I'm just going to simplify a little bit, and 0 to 25, the pi just outside to make it simpler, y dy. And that's a relatively familiar integral you would have seen before. So that will just be times pi times 1 over 2 y squared, which we will evaluate between 25 and 0. And 25 squared is 625, so, and obviously 0 squared is 0, so we'll end up with 625 over 2 pi. Good, and we can calculate the value of that to get the volume of that blue shape. And that's going to be 981.75 units cubed. And we're going to round to 3 decimals. And I'm going to use my units as centimeters. So 982 cubic centimeters. And we know that 1 cubic centimeter is a milliliter. So that will be 982 milliliters, which is obviously just less than a liter. So that's our shape done. The integral from 0 to 25 over the y-axis. And we get this blue shape, a bit like one of those lollipops. And it's got a volume of 982 milliliters. I trust that this was very useful for you. Please leave any comments or questions.